Fourth section of probability, looking at two-way tables. Complete the two-way table. Students were asked in middle and high school which they liked more, math or English. Complete the two-way table below. So these two together have to add up to be 43. Therefore, 43 minus 18 is going to be 25. 19 and this number have to add up to be 31. Therefore, 31 minus 19 is 12. If you add down, these two should be 74. These two sum to 30. And these two sum to 44. You can cross-reference and check to make sure things add up correctly this way and this way if you're unsure of any of your numbers. Number two, complete this two-way table, and this is obviously more complicated because not only they're not giving you the numbers in the table, they don't give you the headings. Let's see if we can figure this out. In a class of 24 boys and 10 girls, so I'm just going to go out on a limb and say we're going to have a column for boys, so this will be a row, and girls. So there's 24 of the boys, 10 of the girls. They were surveyed whether they liked Bieber or Perry. So we got JB and we got KP. 20 boys like Katy Perry. So of the 24, 20 in here are into Katy. 9 of the girls like Bieber. They got that fever. So we got 9 right here. So complete the table. Once again, these two add up to 24, so the missing number here is 4. These two add to 10, the missing number is 1. If you add vertically, we get 13, 21, and 34. Cool. Number 3, class of 35 students. So we know that this is 35. That's the total. We're asked if they were members of the chess club or math club. All right. 16 were in the chess club, 10 were in both, and 9 were in either. So my natural instincts on a table like this is dead wrong, and then panic sets in. Because I look at this and I see, well, there's only two things, chess and math. How am I going to figure out this entire table? Well, if we say this top is math, yes, and this is math, no. And then along the left side, we could say chess, yes. And chess, no. Let's see if this does it for us. 16 were in the chess club. So chess club, yes, over here, it's got to be a total of 16. 10 were in both. So here is the intersection of math and chess, so that means this number here has got to be 10. 9 weren't in either. No math, no chess, this is the intersection, so that's 9. That should be enough to figure this out. So 10 plus 7 is 16. 16 plus 19 is 35. 7 plus 9 is, oops, I made a mistake up here. 10 plus 6 is 16, not 10 plus 7. 6 plus 9 is 15. 10 plus 9 is 19. 10 and 10 is 20. So then we're asked an additional question. What's the probability that a student chosen at random is in the math club? Well, there are 20 students in the math club. There are 35 students total, so that's 20 out of 35. Reduce it if you want. I'm not interested in it being reduced. 14, 15 boys and 16 girls, or 20 girls. So I'm going to assume that we're going to have a boy and a girl. Now, keep in mind, these could be written here as well. Surveyed about music, difference between top 40 and 80s music. So I'm going to call this top 40 and this 80s. 25 students picked top 40. 2 girls picked 80s. Oh, and I forgot this here. 15 boys total. 20 girls total. That means the total students is 35. So 25 and what number is 35? Or 35 minus 25 is 10. 10 minus 2 is 8. That's because 8 plus 2 has to be 10. 20 minus 2 is 18. That's because 18 plus 2 has to be 20. 15 minus 8 is 7. That's because 7 plus 8 has to be 15. Checks out horizontally as well. What's the probability that a student that you choose at random is a boy and prefers top 40 music? Well, how many boys are there that prefer top 40 music? There are 7 of those. How many students are total? 35. Wow, this one doesn't even give you the table. We're banging on all cylinders here. Create the two-way table. High school freshmen were surveyed about their use of Facebook and Twitter. Of the 80 freshmen surveyed, 65 used Twitter, 69 used Facebook, 62 used both. Create a two-way table and then determine this question. So I think this is going to be similar to the one where we had like the yes and no's. All right. All right. So this will be a total down here. Look how the other tables are set up. We got totals at the bottom and totals on the right. So we got Facebook and Twitter. So we'll say use Twitter, no Twitter. Use Facebook, no Facebook. 80 freshmen were surveyed. So that's the total. 65 use Twitter. So use Twitter, this column has the total to 65. 69 use Facebook. This column has the total to 69. 62 use both. Use Twitter and use Facebook. This number here has got to be 62. That's the intersection, using both as an and. So let's see, what can we figure out? This has to be 3 because 62 and 3 is 65. This has to be 7 because 62 and 7 is 69. This has to be 11. 69, 11 is 80. This has to be 8 because 3 plus 8 is 11. This is 15 because 7 plus 8 is 15. What's the probability that a student doesn't use Twitter and doesn't use Facebook? So no Twitter, no Facebook. There are 8 of those students out of a total of 80. So the probability is 8 out of 80. Next page, bunch of questions here. Table's already done for us. The boys and girls of a class were surveyed about whether the class Oh, we got some messed up sentences here. The boys and girls of a class were surveyed about whether the class, this shouldn't be capitalized, had been surveyed about who had been to Canada, Europe, or both. Two-way table shows the results of the survey. What's the probability that a student has been to Canada and Europe? So here's the intersection of Canada and Europe. There are 3 of those students out of a total of 34. So the probability is 3 out of 34. What's the probability that a student has been to Europe but not Canada? So here's the students that had been to Europe but not Canada. So that would be 2 out of 34. What's the probability that a student has been to Canada? 25 students have been to Canada out of 34. Given that they have traveled to Europe, what's the probability that they've been to Canada? So this is a given problem. This is saying, what's the probability that they've been to Canada given that they have not been to Europe? So we look at the not Europe column. Total people have not been to Europe is 29. That's our denominator. Of those, how many have been to Canada? That's 22. That's 22 out of 29. Next table. The boys and girls of the class have been surveyed about whether they have received a speeding ticket or not. Two-way table shows the results of the survey. What's the probability of getting a speeding ticket? Well, there are 10 students that have gotten speeding tickets out of a total of 66 students. So it's 10 out of 66. If you wanted to break that down to a decimal or percent to have a better understanding of what that means, you're welcome to do so. What's the probability of being a girl with a speeding ticket? So how many girls have speeding tickets? Only one. How many students are there total? 66. Statistically, girls are better drivers. 12. What's the probability of that being a boy with no speeding tickets? So a boy with no speeding ticket is 31 out of a total of 66. Who is more likely to get a speeding ticket, a boy or a girl? Well, if we look at the number of boys, there are 40. How many of those got a speeding ticket? 9. So the probability of a boy, let me rephrase that. Probability of having a speeding ticket given that it's a boy. Well, that would be 9 out of 40. The probability that they have a speeding ticket given that it's a girl, that's really what this question's asking, is 1 out of 26. This is 0.225 and this is 0.038. It's better if we write those as decimals or percentages so we can compare the numbers easier. So who's more likely to get it? A boy is more likely. As far as explaining goes, we've done our explaining right there. 14. Wow, this kind of trickled over. Are boys and speeding tickets independent or not? So we had two different tests for independence. Use mathematics to explain your choice. So one of our tests is the probability of being a boy and getting a speeding ticket equivalent to the probability of being a boy times the probability of getting a speeding ticket. If this is true, they're independent. If it's false, it's not true. Probability of, let me bring this table up here so I can see it. Probability of being a boy and getting a speeding ticket is 9 out of 66. Probability of choosing a boy at random is 40 out of 66. Probability of getting a speeding ticket at random is 10 out of 66. As decimals, this is 0.140 and this is 0.092. Those are not the same numbers. Since those are not the same numbers, we would say not independent. And the reason, because the probability of being a boy and having a speeding ticket is not equal to the probability of being a boy times the probability of getting a speeding ticket. All right, we're getting close. Number 15. The town of Centersville is divided into a railroad track that splits the population of the town into two groups, the north side and the south side. And I bet the North Side girls don't mess with the South Side boys. Centerville is having an election for the mayor. Tim Jennison is running against Joe Smith. If the side of town that you live on is independent of the candidate you will choose, how many people do we expect on the north side to vote for Joe Smith? Well, if it's independent of where you live, we would expect this to be broken down fairly evenly. So this probably is a too simplistic problem, and I probably regret putting this on here. Here's what we know. We know that half the votes went to Jensen and Smith. So because of that, these numbers need to be broken down in halves as well. So if there's 60 people on the north side, and these are independent events, that means it doesn't matter where you live, you're going to have half and half. Half of 60 is 30, half of 60 is 30. Same thing here, we got 40 on the south side. If they're independent, you're going to have half and half. And this really oversimplifies what independence is and is not a great problem. The question is, how many people do you expect on the north side to vote for Joe Smith? Well, people on the north side to vote for Joe Smith, we expect 30. It's a terrible problem. All right, relative frequency, and then we are out. What's the probability of getting a red? 40% chance of getting a red. If you wanted to go like pure, you would say 0.40 divided by 1, which is still 0.40. What's the probability of choosing a female at random? 0.44. What's the probability that you choose a green given that it's a male? So here's the males. So our denominator is 0.56. And what's the probability that you choose green given that it's a male? That would be 0.14. You could simplify that if you want. You're going to end up with 0.25. If you don't want to simplify it, that's cool also. What's the probability that you choose a female and blue? Well, here's females. Here's blues. The intersection is 0.06, so that would be 6%. What's the probability that you choose a red or green? Well, this is a little more complicated. It's the probability of red plus the probability of green minus the intersection of the probability of red and green. Probability of red, 0.40. Probability of green is 0.30. Where do they overlap? Nowhere. They don't overlap anywhere because these are independent events, which means I didn't have to have this since they're independent. Can't choose red and green because each person could only choose one color. We got 0.70. Just going to bring this table down here so I can see it. What's the probability of choosing a male that doesn't like green? Well, here's the males, and here's the ones that don't like green, 0.024, 0.18, and 0. So we add those together. Wait, hold on a second. Yeah, we want, let me just make sure this is clear. We want the intersection of males and not green. And that intersection would be here, here, and here. So that would be 0.24 plus 0.18, which is 0.42. Last one. What's the probability that you choose a blue or a female. So this is the probability of choosing a blue plus the probability of choosing a female. Subtract the intersection of choosing a blue and a female. And once again, here's the reason why. If you go blue, that's here. If you choose female, that's here. So we'd be looking at, if we add up all these numbers, we get 0.0. If we add up all these numbers, we get 0.44. If we add up these numbers, we get 0.24. We've added this number twice, 0.06. So blue was 0.24, female was 0.44, and then we added the number 0.06 in there twice. This ends up being 0.62. Don't do the rest of the homework if this is 2020. If it's not 2020, do the rest of the homework.